Welcome to Data Forward, the podcast that keeps you ahead in the fast-evolving world of enterprise AI and data management. We bring you expert insights, actionable strategies, and the latest trends to help you stay on top. Ready to shape the future of data? Let's Data Forward.
Welcome, Pallav, to the podcast.
Thanks for having me, Ashwin.
So, what is your role at Acceldata?
I manage the engineering teams mainly for the on-prem offering related to data observability in Acceldata. And there are a bunch of teams under me, the front-end team, platform team, back-end engineering team, and then QE team. And we all are working towards a single on-prem product called Pulse, which is meant for data observability for big data ecosystem like Yarn and others.
Yeah, so I think there's some context which is required here. So, Acceldata being an observability company, we provide observability across the stack.
Correct.
So, one of our offerings is what you work on, which is Pulse, which is meant for companies and customers, enterprises who operate a large footprint of on-prem data engines, right? And so these data engines could be anything from Spark, Hadoop, and the related set of technologies. We are here to actually, we wanted to spend some time on the optimizer module in Pulse. And it's very interesting because I think we have deployed it in a few customer environments, and there is a lot of benefit that you can see from a customer perspective, but it's not very clear on, what's the need for it, what's the history for it, and how does it go,
Right.
how does it really apply. So if you had to, give an elevator pitch about what is the Pulse optimizer to whoever is listening and maybe prospective customers as well, what's
Yes.
like a 1 minute pitch to,
Yes.
let's say, a prospective customer?
Yeah, so the sole purpose of Pulse Yarn Optimizer is to make the system more performant.
What do you mean when you say more performant?
Right. So typically for a big enterprises, those who have been running cluster of maybe 500 nodes, 400 nodes, they have a big usage of their RAM and core. I'll not take any name of the customer, but one of our enterprise has been using 1000 terabyte of RAM.
1000 terabytes of RAM. Wow.
1000 terabytes of RAM.
Okay.
Right. So with this Yarn optimizer, we could save their 30% of the RAM. So
Okay.
you may imagine like 1000 terabyte, 30%, 300 terabyte of RAM. If we are able to solve with some automated software, it's a huge saving for the organization.
Yeah. And because I think, especially in this day and age, I don't think people appreciate the amount of expenditure which people have to make, especially if you are doing, a kind of a capex on buying hardware, because it's a whole cycle of, getting vendors and making sure you get your hardware, you get your servers, you rack and stack it, enable it, networking. It's an expensive affair. And so if you're able to, let's say, repurpose about 30% of it,
Correct.
then it really saves really a lot of money.
Correct.
So in your case, for the customer that you were talking about, what does 30% translate to? What is the outcome? What can they see?
Okay, so we show them the result in form of evidences that this is pure wastage. So when I'll take a step back. So typically when we start any workload as a developer, we have a tendency of taking 2x more resources.
Essentially, start with more.
Start with more and tune it later so that we can reduce the possibility of failure. At the same time, we also want to be more performant with the system. So let's say one application, if we are using some resources in 2x fashion, and there are 100 of workloads running every day on these clusters. So we are wasting almost double the resources than ideally we should be having.
Correct.
Right. So that's the initial thought process we have started with. And how does it work is in the Yarn way. There is a workload which gets started, and there will be some decision maker on the big data ecosystem or large enterprise ecosystem, which will say that this much of resource allocation required. So generally you go with a manual. Let's say I have to start a workload. I'll say it will require a 2 core and 5 GB of RAM,
something like that.
right? Although I know it might get finished in 1 GB, 1 core and maybe 2 GB of RAM, right? But I'll start with that. And when you send this job for spin up, the only source of truth as of now available on the yarn side is what you set it up.
Correct. I mean, what is that you have configured?
Yes.
And so you're banking on somebody's intelligence to make sure that you are optimizing the capacity correctly.
So here in the yarn optimizer, what we have done is how much real time the job has been using.
What do you mean real time?
In actual. In actual, let's say
during the
course of
during
the total course of this job life cycle, right? We have started with, okay, how much maximum it has been using. At least we can start doing the configuration maybe 10% or 20% more than that. Then the next step for us was, we have actually started fingerprinting these jobs, that when it starts, it requires this much of a core and this much of a CPU core and this much of a RAM. Then after maybe a minute, it will require this much. So the change of resources is not static. It keeps changing. CPU will depend upon how much, because it's a shared resource of course.
But there's also some aspect of seasonality, isn't it? I mean, depends on what other things are running at the same time. Yes. What is the time of the day where it's running?
Correct. So that's how we have started with this thing called fingerprinting. So when we start doing the optimization for any of the cluster, we take about 7 weeks. Not 7 weeks, 7 days.
7 days, okay.
To identify the pattern of the jobs.
What does the pattern of the job mean? I mean, you said there are thousands of jobs. So what does the pattern mean?
So thousands of jobs, probably, let's say there are 10 users. They have been running the repeated jobs. The repetition can be in any form. Maybe they have a different name. I mean, they are identifying their job by their name, let's say marketing jobs or Ashwin's job, Pallav's job.
Correct.
But there can be other dynamicity also. Let's say some other thing, like let's say fingerprinting, if I have to say that Ashwin's job on so and so day.
Correct. Okay.
And Ashwin is running job every day, the same job, but only the date part is getting changed.
So when you say fingerprinting, it's like uniquely identifying some
repeated jobs.
Repeated jobs.
Yeah.
What are some of the parameters which you use to actually fingerprint the job?
Yeah. So we have actually given a very flexible system to the user.
In the sense it's configurable?
It is configurable. We have support for grok pattern, where you actually start just by the name, or you say this parameter will be dynamic. In this case, the date was dynamic parameter.
Correct, yeah.
Or you can actually have an option of ignoring some jobs. Let's say some jobs are just regular ad hoc jobs or side jobs, which takes let's say less than 1 minute. I do not want optimization that. You can ignore them. So once you identify that these are my repeated jobs every day I run, and I need optimization on those jobs, I can start enable the optimization system.
So, especially with this sort of ecosystem, right? I'm sure that for you that it is difficult to also differentiate signal from noise, in the sense that there is so much telemetry which comes, right? So they use like CPU, memory, network, and RPC. There's so much. So how do you, number one, handle this sort of telemetry? What do you do with all the metrics that you get? How do you sample it? Or maybe you can share some technical details on how it's done.
Yeah, it's a great question actually. The number of metrics are overwhelming. And we also took some time that the metrics which are actually changing in the system, we just take those metrics into the account.
Okay.
Right? The constant metrics are anyways, for example, CPU, memory, RPC. These are the important metrics which are generally we have seen a pattern of change.
Correct.
Right? Then with the fingerprinting, we know that let's say a job is of 6 hours. First 1 hour, I'm just taking the sampling data little for a longer time. 1 hour is a very long time, but let's say first 1 hour it will require X CPU, Y memory. Maybe in next 1 hour it will require 2X CPU, 2Y memory, right? So we know, because we already have the fingerprinting, that how much resources it will require in which part of the tenure of this application, right? And when you combine all these 100 different applications, right, then you actually see the saving happening.
What does saving mean? I mean, you mentioned that, okay, you save 300 terabytes of RAM, but what does saving mean in the sense how does a customer know that they are saving?
Yeah. So what we do is typically that there is a fingerprinting. The second thing is the calculation part, where we will arrive this sort of result that ideally what is the ideal usage of this application, and the third part is the instrumentation of those uses.
Correct.
Through the API. So let's say 2x was requested by the developer, but we realize only x is needed. We will instrument just the x.
So you change the configuration at runtime so that maybe you can submit more jobs, something like that?
Yes. So the job which was stuck because already 2x have been taken. Let's say the total capacity of the system is 2x, and the 2x has already been requested by the developers. Now you are saving x out of it. That means you can spin up another x sort of jobs.
So more jobs get scheduled,
Yes.
and that is the outcome that a customer sees.
Less number of failures, more jobs have been scheduled. You can see the containers, number of containers going up.
Right. So yeah, so I get it now. So the way saving is immediately seen by customers is that they see more utilization of existing capacity.
Yes, there are two parts to it. Let's say there are more jobs which are waiting outside, they'll start getting spin up.
Correct.
The second is, let's say there are no jobs waiting, then you will see the utilization going lower and lower, which you probably can decide at later point that I do not need these many resources. You can cut down the resources on that system.
The resources and probably use it somewhere
elsewhere. Yeah.
I also some of the discussions that I've heard you guys have is around the fact that something like this is not just required for very specific systems. For example, we were talking about Yarn and Hadoop and such systems.
Yeah.
But it is also extendable to anything which has some sort of a resource pooled resource clustering sort of technology like Kubernetes.
Yeah.
So have you guys experimented with other systems outside the the usual suspects?
Yes, we have been extending it to various other large data ecosystem scheduling platform. Kubernetes is one such platform with which we are starting. And see, these system will have some scheduling mechanism.
Correct.
Then there'll be a decision maker who will decide that how much resources will be providing to whom. And obviously the lower level entities, like in case of Yarn, it will be container. In case of Kubernetes, it will be pods, right? So, but the core logic remains the same, that you try to find out the wastage, you instrument the right resources to the jobs or workloads which are running, and then try to leverage the extra resources which you are saving for spinning up more workloads. And it has been working well with other ecosystem also, although there are early trends. And it is not just the Acceldata, other companies are also have been trying. I was actually seeing there has been some good work done by IBM also in the same.
So IBM is trying for their own Kubernetes clusters to try and
optimization,
optimize workloads.
Yes,
essentially. Interesting. What's the kind of skills that an engineer should have to work on this sort of systems that your team works on?
It's an interesting question. So I would still go with the basic fundamentals of computer science, which is you should be knowing one primary programming language. It can be any language which includes Go, Java, Scala, anything. Then the person should have a good database knowledge. One database is good enough. SQL, no SQL. And I think the system knowledge is very important. How the infrastructure has been set up. What is CPU? What is memory? All these things. And then some terminal knowledge. Let's say Linux, right? Overall operating system. How do they work? So I think with the combination of all this, I am very sure that any person can scale up to the work which we do here.
With any discussion these days, the topic of AI eventually, creeps up somehow or the other.
Right.
And now talking about this optimizer, where there is some complex decision making happening with, and we discussed about action, which is kind of decision making based on metrics to do what or not. Do you think that there is a use case to be made where something like maybe an AI with a focus emphasis on, let's say, fast inference, high speed, actually make scheduling decisions on clusters as well? Because right now it's largely algorithmic, right? You use it as like a first in, first out, or some sort of a resource scheduling algorithm. Do you think there is like a good use case to be made that if the inference is fast enough, then something like scheduling pods on a cluster, scheduling containers on a network can be actually done by an AI?
Yes. Actually, we have personally experienced it. We tried our own algorithm in the Kubernetes world. So generally, the standard scheduling algorithm on which Kubernetes works is whichever pod or whichever node has less load, they will try to schedule their pods on them. Versus what we have tried out, the maximum capacity of a node. Let's try to leverage that first, then only schedule the nodes, schedule the workloads or pods to the next node.
Next one, okay.
That way, we identified actually that if you see in a month's time, there were bunch of nodes which were not touched at all. Right?
In the sense it's underutilized or not utilized.
They were not utilized at all.
Okay.
So you can very well go and remove those nodes because you were able to do with your standard workloads to the workloads on which we were to the nodes on which we were actually running these jobs. So yes, short answer is there is definitely a possibility of optimization in the scheduling side of work.
Even using, instead of using a specific algorithm, plugging into an AI system somehow.
Yes, I'm agree.
So for those who are watching and maybe find this sort of work interesting, what would be your 1-minute pitch to come and work with you at Acceldata?
Yeah, in my opinion, Acceldata is a very good company for the quality of the work. And there is a good work-life balance. And there are good opportunities to learn the forward-looking technologies, including AI. So our products has all this variety, all the kind of standard work ethics, etc. So I think it's a perfect blend of everything which you will wish for to have in your workplace.
Great. Thank you, Pallav. This has been a great conversation.
Okay, thank you, Ashwin.
Welcome to Data Forward, the podcast that keeps you ahead in the fast-evolving world of enterprise AI and data management. We bring you expert insights, actionable strategies, and the latest trends to help you stay on top. Ready to shape the future of data? Let's Data Forward.